question of the year. Who's excited? Me? Me? Okay. All right. 10.5, abuses of statistics. Did you know that people abuse statistics? They do it all the time. And I want to show you some of the common misuses or abuses of statistics. So some of the abuses of statistics have to do with who's asked. So we just went through a presidential election, right? Depends on who you ask as to what things were going to turn out. So all exit polls, everybody's always a little skeptical. Did we heavily, sample people that were more on leaning left or leaning to the right? That kind of stuff. So we have that sort of an issue. Who was sampled? Was it really random? Those kinds of issues. How many people were sampled? Because if I ask 5 people and I'm trying to apply that to the whole nation, well, not so good, right? So we know how many people were answered and were asked to answer it. Not only how many were asked, but how many responded. Because I don't know about you, but sometimes people send me little surveys to complete and I don't answer. So it doesn't matter if you send out 1,000 surveys if you only get 5 back. We've got the exact same problem as if you only asked 5. Was the sample random? Did we actually sit and ask everybody that came to OU's campus? Because that probably doesn't apply to the university, not to the university, but to the nation as a whole either, right? Or did we sit outside of Wall Street and only ask people in New York? Again, not so random. So we want to make sure that our sampling is pretty random to make sure that we can apply them at large. The other thing is, how is the question worded? Is the question worded in such a way that it leads you to want to answer a question? So if I ask you, do you ever lie? No, I don't lie. But then you start to define what does it mean to lie, and you have to be really careful, right? This kind of stuff. So how is the question worded? Or sometimes, you and I have talked about this before too, Sarah, do whoever you're asking even understand what you're asking them? Right? Do they know what you're talking about? Is it worded in such a way that makes sense, or is it in language they can understand, or enough of the language they can understand it? All right, so we also have graphical representations. So your graph should include a title, and I've been terribly sloppy as we've been working about putting titles on. The title can be in the way of creating a graph or in the description of the graph above it. Does it tell you what the heck you're looking at? Right? This is important. Do you have labels on both axes or on all sections of the pie chart? And we have to be more careful about that, putting a label on the vertical and horizontal axis, what we will be talking about here. Source of the data included, right? So if we only interview people at OBU, it should say that somewhere on there. Because that's going to change how we interpret our data. A key to the pictograph shown. So if you created circles and they represent 5 million, like the one you're talking about, Jennifer, it needs to say that the circle is 5 million. Because if the circle is 5 million or 5,000, it would be different, wouldn't it? Yeah. Uniform size of the symbols on a pictograph, which we have talked about, right? The size on your pictograph needs to be the same. You make one of them really big, you make one really tiny, and then somehow things get lost in translation. The scale doesn't start with 0. We've addressed that issue too. We've had breaks in the scale when it hasn't started at 0. We're doing that. And then on the scale, or the space is evenly spaced. We talked about that earlier today too when I created the box plot, right? I said make sure your scale looks reasonable, but it really looks like they're evenly spaced. Because if you don't make it evenly spaced, it can be very misleading. That, oh yeah, it looks like there's an even disbursement. No, because it went from 18 to 37. And the mean was at 19, that's not an even disbursement, but on the picture, so it looks like it is. That's not good. And then the other issue is a 2D versus 3D misleading effects. So when people two-dimensionalize or three-dimensionalize or something, a picture, particularly usually 2D and 2D and 3D like a pie chart, sometimes it doesn't look exactly like it should look before. Let me show you that one example and then we'll stop. Take your book and flip to page that's the only one I have to really explain to you that. Take a look at page 619. 619, let's go ready. 619 has a graph in the dead center of the picture. You see the bars and their height. It's number of cars sold by car lot. And it may in fact be that 2011 had the most car sales. That's possible. But there's 2 issues going on here that make this misleading. One is the three-dimensionalized sort of feature to this. I mean, 2011 was humongous compared to 2008, doesn't it? Not only that, but the scale scale is also not head-on, it's at an angle that makes that look perspective-wise much larger as well. If you look above it, right, the two-dimensional graph, that graph right there shows the actual data. 2011 actually had the same, or very close to the same, the first test as 2009. I can see that on the first graph. On the second graph, it didn't look like that at all. So the thing I'd like for you to take away from this section, in particular as you do your homework, is that you face misleading information like this all the time. It's in textbooks, it's on the media, it's in magazines, and you can't fix the fact that people do that, but you can fix the fact that you look at it and say, now wait a minute, something about this doesn't look right, and look at it with a critical eye. And that's what this particular section is about. Okay? Looking at graphs and looking at representation, sampling processes and whatnot, and asking the questions to say, is this really what's going on? And if not, why not?